Now that we have understand what is sound, let's understand more on sound waves. We will start by watching this video on sound waves.
Waves are produced as a result of vibrations and can be classified as transverse or longitudinal. Whether they are transverse or longitudinal depends upon how the particles are made to vibrate as the energy passes. Let's look at longitudinal first. This is where the particles vibrate parallel to the direction in which the wave of energy is travelling. Notice that the ends of the slinky don't ever leave the hands holding them. It's only the energy that travels. The places where the coils or particles are bunched together are called compressions. Where they are furthest apart are called rarefactions. An example of longitudinal waves is sound. When a drum is struck, the drum skin vibrates, which causes the air particles next to it to vibrate. This causes the next air particle to vibrate, then the next, and so on until the vibration reaches the ear, causing the eardrum to vibrate. The vibrating air speeds away from the source, creating a sound wave.
I'll explain more on this. So this is air at equilibrium, means there's no vibration that creates the sound waves. When there's sound waves, the energy will be transferred through the air. So here will be compression and here will be rarefactions. When there's gaps, there's rarefaction. When it's closer to each other, it's compression. The sound waves can be represented in graphs. At compression, the amplitude is higher. And at rarefaction, the amplitude is much lower. One complete cycle is called wavelength. We are familiar with this term, frequency. But what is frequency? Frequency is vibrations per second. For example, when an object produces sound waves and the sound waves vibrates 100 times in 1 second, the sound frequency will be 100 Hz. I will share another example. 440 Hz means there's 440 cycles in 1 second. So what are the difference between different hertz? Let's go to this website to experience the sound. If you are using headphones, you might want to reduce the volume a little bit. Now, let's key in here 250. 250. I'm going to press play. So that's 250. Then I'm going to key in 350. You can hear the difference, right? And the last one is 450. So based on what we hear just now, lower frequency means lower pitch, less cycle per second, and higher pitch means more cycle per second. So just now is understanding on frequency, number of cycle per second. But what are the difference between higher amplitude and lower amplitude? Higher amplitude means louder and lower amplitude means quieter. You might be familiar with this graphic here that's usually represents sound, this one. So this longer vertical line shows louder sound and the shorter one shows quieter sound.